Hello amazing learner, welcome back to the Zoom Chemistry Hub. Today in this short video we will discuss different steps by which we will draw the lever structure of different molecules. So first we will discuss the different steps. So the first step is that first we will count the total number of valence electron of all the atoms present in a molecule or ions. For ions, we add the electron for negative charge, and for cation or for positive charge, we subtract the electron from the valence electron. In the second step, we choose the central atom. We usually choose the least electronegative atom except hydrogen. So hydrogen and halogens are usually the outer atom. An example is that in NH3 the nitrogen is central atom and hydrogen is the outer atom. In the third step, we connect the atom with a single bond. We use the single lines, that is the 2 electron, to connect the atom to the central atom to make the structure of the molecules. And we know that each lines contain 2 electrons. In the fourth step, we distribute the remaining electron as a lone pair, first on the outer atom, then on the central or inner atom. So first we complete the octet of the outer atom, then the central atom. And each atom except hydrogen should have 8 electrons, that is the shared and lone pair. And hydrogen only needs 2 electrons as a duet. And in the fifth and last step, we make double or triple bond if needed. So if any atom, especially the central atom, does not have 8 electrons or do not complete its octet, we move the lone pair from the nearby atoms to form double or triple bond. For example, in CO2 has 2 double bond for carbon to complete its octet. Now we will take the examples. That is, first we will write the formula of hydrochloric acid, that is the HCl. Then we will count the total number of valence electron of all the atom in the molecule, that is the hydrogen is in the group 1, so it has 1 valence electron. Similarly, chlorine is in the group 17, so it has 7 valence electron. So that gave us a total number of 8 electron by adding these valence electron of the 2 atom. Next we will choose the central atom. In HCl there are only 2 atoms. Hydrogen can form only 1 bond, so it is always go on the outside. So chlorine is in the central atom by default. In the third step, we connect the hydrogen and chlorine with a single bond to make the structure of the molecule. So this single bond or line represents the 2 shared electron. And in the fourth step, we distribute the remaining electron to complete the octet rule, especially for the chlorine. We have used 2 electrons for the bond between the hydrogen and chlorine, so we have 6 electrons left, and we place them as a lone pair on the chlorine atom. Now we will check the octet of the atoms. So in the last steps, we check all the atoms follow the octet or duet rule in the case of hydrogen. So the hydrogen need only 2 electrons, and chlorine now has 8 electrons, 2 from the bond between the hydrogen and chlorine and 6 from the lone pair. So the structure is complete and chlorine complete their octet. So both the atoms are now happy to complete their octet and duet. Now we will take the another examples of carbon dioxide. So in the first step we will count the total number of valence electron in the carbon dioxide molecule. So in the carbon dioxide molecule, first we write the formula, that is CO2, and in the CO2 the carbon is in the carbon belong to the group 14, so it has 4 valence electron. Similarly, oxygen belong to the group 16, so it has 6 valence electron. So the total number of valence electron of carbon and oxygen are 4 electron for carbon and 6 electron for oxygen. Here the number of oxygen atoms are 2, so we will multiply their number of atom with their valence electron. So the total number of valence electron of carbon and 2 atom of oxygen are 16. Now in the second step we choose the central atom. So we choose the less electronegative element or atom, that is in the carbon dioxide the less electronegative element is the carbon, so we will make the carbon as a central atom and it goes in the center. Next we will connect the central atom with the outer atom by a single line to make the structure of the molecule. So we connect each oxygen to the carbon using a single bond, and each bond use 2 electrons, so 2 bonds equal to the 4 electron. Now in the fourth step we distribute the remaining electron. So we distribute the remaining 12 electron to the outer atom first, starting with the oxygen, and give each oxygen 6 electron as a lone pair to complete their octet. So each oxygen have 3 lone pair of electron on either side of the carbon atom. So the total number of electron in these lone pair are the 12. Now we will check the octet of all the atoms, either complete or not. So in the fifth step we check the octet. Both oxygen have 8 electron but carbon only has 4. That is not enough, so the carbon is unhappy, and for making them happy we complete its octet. So we form the double bond with carbon and oxygen to complete the carbon octet. So we need to form a double bond, and we take one lone pair from each oxygen atom and form a second bond with carbon. So carbon complete its octet by making another bond with each oxygen atom and to form with double bond with both the oxygen atom on either side of the carbon. So here now carbon complete its octet. Now all the atoms have completed their octet and they are happy now. And finally we check the structure, that each atom now has full octet. Carbon is 8 electron, form 2 double bond with each oxygen atom, and each oxygen has 4 share electron and 4 non-bonding electron as a lone pair on the oxygen atom to complete their octet. We will take another examples of ammonia molecule, NH3. The formula of ammonia is NH3. First we will count the total number of valence electron in the NH3 molecule. Here the element nitrogen is in the group 15, so it has 5 valence electron, and the hydrogen belong to the first group, so it is 1 valence electron. So the total number of valence electron in the NH3 molecule are 8. By adding 5 valence electron of nitrogen and 1 valence electron of the 3 hydrogen atom are added, and to make the total number of valence electron are 8. In the next step we will choose the central atom. So we choose the central atom. Nitrogen is less numerous and form more bond, so it is the central atom, and hydrogen will be bounded around it. We know that hydrogen is always on the outer side because it forms one bond, and we place the nitrogen in the center and 3 hydrogen around it in a triangle. In the next step we connect each hydrogen atom with central atom nitrogen by a single bond to make the structure of the molecule. So connect each hydrogen atom to nitrogen. So connect each hydrogen atom to the nitrogen using a single bond, and each single bond use 2 electrons. So 3 bonds are formed between the 1 nitrogen and 3 hydrogen atom utilizing 6 electrons. So in the next step we will distribute the remaining electron. So 2 electrons are left, and we place the remaining 2 electrons as a lone pair on the nitrogen atom, because here the 3 hydrogen atom already completed by making a single bond with nitrogen atom. So we will now complete the octet of the nitrogen atom by putting the 2 remaining electron on the nitrogen atom. And in the last step we check the octet and duet of the hydrogen atom. So check all the atom follow the octet rule. So the hydrogen need 2 electrons to complete their outermost shell and obey the duet's rule. And nitrogen is 3 bond having 6 electrons in their outermost shell and 1 lone pair on it. So it complete its valence shell, and follow the octet rule. So all the atoms are now stable by completing their outermost shell. And that's it. You have successfully drawn the Lewis structure of the molecule step by step. For more chemistry videos, don't forget to like, subscribe and share my channel. Thanks for watching.